that is and that is what is suggested, that if you have got 50 pies, go through the records of all the 50 pies and select the one where there has been some kind of abnormality, whether it has been slump loss of concrete, discontinuity, or bad concrete, or you have some doubt in the termination criteria, or the quality of rock or something like that. Whatever abnormality you find, then those pies need to be selected for the testing. For integrity testing, there is absolutely no issues because it is so cheap and so fast that generally person goes for 100% testing as far as integrity test is concerned. Dynamic load test, again, you can go for slightly more number of pies because it is lot cheaper than static load test, but lot costlier than integrity test. So there has to be judicious understanding of decision of how many pies need to be tested. And second is that this is IS code which gives routine test. This test is required for one or more of the following purpose. The number of tests may generally be 0.5% of the total number of pies required. The number of the tests may be increased up to 2% in a particular case, depending on nature, type of structure, and strata condition. And the purpose is one of the criteria to determine the safe load of the pile, checking safe load and extent of safety for the specific functional requirement of the pile at working load. Okay. A routine test is done on the field pile, working piles. Working piles are those piles which will bear the load of the structure. Initial piles are usually exploratory piles and they are not used as working piles. Normally, in very rare cases, initial pile is used as a routine pile, because initial pile load test, most of the time they are tested to destruction. Destruction, it doesn't mean that crushing of the pile, but extra settlement. Many times if you see that initial pile test criteria, and suppose you have to determine the pile capacity by doing initial load test, then one of the criteria is that 3/4 of the load at which the settlement is 12 mm, or 50% of the load at which the settlement is 7.5% or 10% of the diameter of the pile. So that pile is tested to the limit where it can no more take the load. That's why initial test piles and working piles are different. They are never used for the structure.
So Panditji, we have 5 minutes more.
Yeah. 5 table, I tried to explain what kind of pile type and what kind of testing has to be done. So initial pile test is exploratory and it is done by static load method. Low strain, high strain is not used for this. Routine pile test is done on working piles. Working piles, those will be the part of the structure. All the three kind of tests can be done. Low strain is very much fast, cheap, and that is most preferred. End bearing pile, low strain is really good enough. If the rock strata is good, then we don't require actually a static load test. Knowing that concrete is good, knowing that the pile shaft is good enough to ensure that the pile has got enough capacity. Friction come end bearing piles, we do both static and high strain. Low strain is not good enough for friction piles. For driven piles, again we can go for low strain because driven piles are usually, if it is precast, then the quality is already known. We have to know only that there is some, if there is any defect has occurred during driving down, hammering it, cracks, micro cracks, our pile has broken, not broken. So that's why low strain test is quite advisable for driven piles. What is happening?
So
Okay, just one or two slides. Let me check.
You can continue, no problem.
So there's some problem. Okay.
Okay, so
नहीं नहीं हाँ, पूरा एंड में जाने का है हाँ अभी दिख रहा है ये? Okay, Anandji, this was actually the last slide, and then the next slide is only thank you, ask question.
okay, so fine, thank you so much. So in spite of a lot of adversities, I think you could finish your lecture presentation. So now we have time to take a few questions. As I see in the QA box, there are very few questions, or almost there are no questions, I would say. And two questions asked by Mr. Teredis have been answered by Pandey ji. I don't know whether they are visible to everybody, but I'll just
आनंद
yeah,
शिखर वैश्यम पाईन जॉईन झालेले आहेत तर
yeah.
त्यांचं पूर्ण करायचं का त्यांना किती वेळ
हा,
द्यायचा ते सांगायला लागेल
त्यांच्या I think 2 slides आहेत फक्त. Mr. Vaishampain, would you like to?
Yes, I would
Restart?
prefer to
Yeah.
finish that up so that there's a completeness.
Yeah, sure.
Can I just do a slide share?
Yes, yes.
Okay.
So can we just start? Yeah.
We
right.
were here actually when we stopped.
Yeah, yeah, right.
Right, sir. So, okay. Okay, sir. Okay, so we were at this point where we are talking about the similarity of the pile penetration ratio method with the chisel penetration energy method. And we pointed out that the energy per square meter area for the defined or for the penetration that is actually achieved. And the important part, what was that was pointed out was that the torque T, which is a part of this equation, actually cannot be found out by field observations, but it is dependent on the observation in revolutions of Cayley per minute, RPM of the Cayley, and that is to be taken from here. So the for higher RPM, lower torque; for lower the RPM, higher torque. And around 9 to 10 value, you get maximum torque, and that is where one tends to stop. So let me go to the next slide from here. So typical pile penetration ratio values rates for rotary auger piling rig with a typical torque value of 180 kilonewton and at RPM 10. So we are just going to look at that, and the pile penetration ratio when it is around 500 to 750, the type of strata usually is soil, and the rate of penetration is 40 to 60 centimeters. When the torque, I mean, I've just given typical values. When in highly weathered rock, the penetration is 20 to 40. In moderately weathered rock, the rate of penetration is about 10 to 20 centimeters. And in slightly weathered rock, where the rock is hard, the penetration would be between 5 to 15. And the corresponding pile penetration ratio values would be between 3,000 to 6,000 kilonewton per meter square per cm. The PPR value will be that much. What is seen actually is that these values are so many times more as compared to nearly 20 times more as compared to what you see in chisel penetration test. In slightly weathered rock, this value would be around 600 or 650 or say 700. Now this is practically 10 times the value for slightly over the drop. Or when the rate of penetration drops down to 5 centimeter, the value would be 6,000. And at if it use a chisel there, the chisel penetration energy value would be around 600 to 700 kilonewton meter per meter square per centimeter. So that is one interesting aspect, but which I wanted to bring out to general notice. So you do not compare PPR and chisel penetration energy apple to apple. They are different kind of values. Then I'm coming to a very important point here. Some people suggest that let us go to site, let us not do any investigation work, go to site and directly drill a pile, bring a rig and drill a pile there, and find out what is the chisel penetration energy or what is the pile penetration ratio, and based on that allow us to estimate the pile capacity. Now that is something which is just not possible to do. That is basically in the absence of geotechnical investigation data. These are all chisel penetration energy or pile penetration ratio are related to the geotechnical investigation data, kind of core recovery, kind of RQD, kind of crushing strength what you get. When you connect these aspects together with the energy levels, and then only you can come up with the proper answer. But otherwise, to estimate the pile capacity in the absence of geotechnical investigation data is very hazardous. That is a caution actually I'm putting up here, or alarm, let's say. Now we are going to look at a typical case study, what we have carried out. I mean, this investigation are done by us, and this is Epicon site. Okay, the staff quarters at Sion, Mumbai. So let us look at this case study. Most of it is only slides where I would be speaking very less. This is a typical bore log. You can see that the rock is starting at around 6 meters, which is most of it is completely with the rock with a nil RQD up to 9 meter depth. Only after 9 meters, the RQD builds up and core recovery crosses 75, 74, 60. Basically, it crosses 50%, I would say. So this is where possibly pile would go and probably get terminated. So considering that as that in the mind, these parameters were set out. Safe pile capacity was limited to 400 kilonewton per meter square because the crushing strength of rock was low. So the expected pile diameters were for various diameters, the capacities have been worked out, but in a safe wind bearing stress has been kept very low, 1000 kilonewtons per meter square. Normally that is equal to 100 tons per meter square. So you can imagine that this is a low value. Then the safe friction stress of the weathered rock has been kept at 125 kilonewtons per meter square. And the minimum rock socket length is taken as 6 times pile diameter. Now, in this particular site, 600 and 800 were chosen as the suitable values. Why? We'll see in the next slide. You can see the load carrying capacity of 600 dia pile is 1131 kilonewtons, and for 800 dia it is 2011. This was a typical layout where this you can see the biggest staff quarter is a residential area and columns are pretty close by, and these are the column positions actually which has been developed by Epicons only. From 2nd to 9th floors we have, and the grid has been very properly established, and this is how this is a ground plus 9-story building. Ground plus 9-story building would be a moderately loaded building. Here in this case, the load would be around and about 300 tons to 400 tons. You can see here that vertical loads are have been actually what has been done actually here is they have been grouped actually into 2 piles, 3 piles, 4 piles, and raft. You can see that for 2 piles the loads are 2251. For 3 piles they are 3391, and for 4 piles it is around 4000. And the G4, which is a lift area, also the columns are very nearby, and there's a concentration of loads there. So pile layout has been fixed according to that. The raft area which you are discussed just now near the lift actually has got maximum number of piles which are selected as 800 mm diameter. And for group G1, group G2, G3, G4, G5, all actually they have been selected as 600 diameter piles. They are mostly 1, 2, 1, 3, 1, 2 piles, 3 piles groups, and 4 pile groups. There are 4 pile groups are at the bottom. You can look at G7. G7 are at the bottom below lift actually, and G8 is the only one which has got higher number of piles as well as pile diameter is also more. Now for this, what are the termination criteria specified? Let us look at that. These are calculations actually defining that how to number of piles, the way number of piles are calculated and all that. I will not go much into this, but then look at the pile termination criteria. So we fixed unit time interval as 10 minutes, which was kept constant. Sorry, drill depth achieved in a standard time interval was recorded. Then kVAR RPM, pressure gauge reading, and strata log actually have to be maintained with each interval. The pressure gauge reading is important because pressure gauge reading actually tells you whether the pull down force is applied. If the pull down force is not applied and you can do some jugglery, then the RPM of the kVAR can be controlled, or there's a chance. So to prevent that kind of chance or manipulation in the field, the pressure gauge reading is very important. So pressure gauge reading with kVAR actually have to be read together. It is like saying that I'm tightening a screw into the wall, and I have to apply a lot of pressure to on the screwdriver to push the nail inside or push the screw inside. A similar kind of thing is here. Then on reaching the rock stratum, soil auger was replaced by rock auger. And we discussed about the difference in soil and rock auger. And with improvement in the stratum, you will see that the penetration as well as RPM both will start reducing. The significance of RPM dropping is increasing the torque. So at 9 to 10 RPM and pressure reading about 20 MPa, penetration drops below 10 centimeter. Now this is a typical observation seen at this site. And in this strata, one minimum rock socket length of 1 diameter was achieved. Rock samples were corresponding to each penetration were collected at each and every pile, and they were stored and labeled. And then this was basically correlated with the nearby trial boreholes on meeting rock specified, and then the seen that the specified minimum required length of pile was achieved. Now it was ensured once again that minimum 1 diameter of the socket, bottommost diameter, was in good rock below soft pocket. So we discussed in chisel penetration energy of 225. Here the PPR would be somewhere around 4,000 to 4,500 kilonewton per meter square per centimeter penetration. That is it. This was all that was balanced in my presentation. So thank you very much. I would request you to take back the control.
Okay, thank you, Mr. Vishampayan, for rejoining and completing the presentation. So we are exceeding the time limit because we have to give some 10 minutes again for filling the same Google form again. But we'll quickly go through a few important questions or interesting questions. Before that, I have one question for Mr. Pandeyji. In fact, I had a couple of questions, but out of that high strain versus low strain applicability issue that you have already answered. The second question is, if we compare the static load test and the dynamic load test and derive at the pile capacity, so how do they compare? Which one is more reliable? Is Mr. Pandeyji there?
Hello. Yeah.
Yeah.
The most reliable is the static load test.
Yeah.
Okay.
So
because it's using the actual gravity load, there is not too much of inferences, mathematics and equations and assumptions. So those are not involved as it is involved in dynamic load test. Low strain test anyway doesn't talk about any capacity or settlement issue. It only talks about the soundness of the concrete shaft.
Integrity of the pile.
Integrity of the concrete shaft. That's all.
Yeah.
So out of dynamic load test and static load test, for the initial test, only the static load test is the most reliable method. And if there is a sufficient data from static load test and dynamic load test together, then dynamic load test becomes reliable. because there is a benchmarking with the static load test. So the testing agency, suppose they have done this kind of correlation and they have this, then dynamic load test may be as reliable as a static load test in that case.
Okay, fine. Thank you. So we are going to take only few questions. So there's one question about what does it mean by soft toe, which is shown integrity test report of file. Can we use this file or we have to discard this file? Or any further testing is advised?
Yeah, this soft toe is a slightly dicey situation, because conventionally the soft toe means there is a debris or accumulation of loose material at the tip of the concrete, end of the concrete, and between the rock socket. So that situation is called soft toe, and this it results in excess settlement. Whereas our limit is suppose 12 mm settlement. But if the debris accumulation is 50 mm, 60 mm, then it might give the settlement of 25, 30 mm. So it may not be that pile is ultimately weak or it cannot take the load, but it will give extra settlement. You see, and soft toe case is always in the case of end bearing pile, when there is a rock socketing, when there is a trimmy concrete, and water is filled in the. So soft toe cases are very rare. I would say common only in case of end bearing and not in friction bearing. And since it is end bearing, the initial settlement is only just few mm for a proper pile. And with a pile with a soft toe, it will be slightly more. So there is no need to discard this kind of pile if there is no other defect. However, if the structure is very tall and if it is very sensitive for settlement, differential settlement, then load test or dynamic load test. In fact, the static load test is the best for this kind of situation. If you want to really ensure that, and if the structure is so much sensitive. For normal structure, I don't think that pile should be discarded or any other test is required.
Fine, thank you.
Can I add
So
something?
Yeah.
Okay.
Yeah, sure.
Okay. Basically, what happens is that soft toe happens. Why does soft toe happen? First of all, let's get to that. It is basically because the certain amount of limitations which are seen in the hydraulic rotary rigs actually. When there is a rather large thickness of clay of this thing, and we are not in a position to provide full length of the casing for soft clay patches or say cohesionless stratification, then what happens is this soil actually collapses. And whatever you do, however, supposing even if you tend to use, let us say, polymer fluids in place of DMC, or then in place of bentonite, even if you use polymer fluids, it is our experience that such piles tend to have or develop soft toe. And in some of the sites, we have seen soft toe in numbers up to 30%. So, as a design engineer, suppose I'm sitting across you, then my advice to you would be that we should discard those piles. The piles structurally may be okay, but then if they're going to settle down and going to affect the serviceability of the structure or structure in question, then they cannot be dependent on, because the K value of the pile, in analysis would be totally different. The spring constant would be totally different. Spring constant will be defined by capacity of the pile divided by the deflection. So here deflection will be in excess of 18-20 mm. If that is so, then it's really questionable.
So we will have some differential settlement issues,
Yes.
and structural cracking. So
No, in case of
we have yeah.
In case of
Yeah,
end bearing pile, that settlement will take place only at the time of foundation. At very low load, very less load, that settlement, entire settlement will take place. It will not keep on taking settlement at the later stage, especially for end bearing when the pile is on the rock. So that aspect should be considered.
Yeah. So now we have a couple of questions which are asking about the modeling of the pile.
I think we should go ahead.
So
Okay,
that
thank you.
Yeah.
Both of them have given their own.
Yeah, viewpoints. So there are a couple of questions which are related to the modeling of file in StatPro or some other software. So I think this is not the subject currently for this webinar. So we might take up this as a separate topic. And there are two topics which remain uncovered today. One is there's a question on lateral load test on file. So how to determine the lateral load capacity of the file. And the second question is regarding when to use the pile draft. So are we in position to take up these two questions now?
I think pile draft, yes, Vaishnapan sir can answer in brief because it's an independent topic. Instead of I answering, Vaishnapan sir, pile drafts, there are Sankat, at least.
Yes, definitely. Yes, actually, we had a detailed lecture, if you remember, sometime back, maybe about 2 years ago, in your premises, where this was elaborated upon. And
the question is from some other participant.
I know. Yeah. I'm going to that point. So basically, what tends to happen is that we have very heavy structural loads or a large magnitude of loads per column, and we require SBC, let us say 70-80 tons per meter square. I'm just taking a case, or say 700 to 800 kilotons per meter square, and stratification available at the bottom of the basement, let us say, is offering only 30 or 40 or 400 kilotons per meter square. So there is a gap between the required capacity and or required stress, the incident load actually, as well as what is capacity of the material or capacity of the founding stratum. In such case, in such cases, typically the pile draft actually is used, because then whatever capacity cannot be taken by raft is supplemented by putting extra piles. Now, how to do that? I mean, you can do regular grid of the piles, or you can do wherever there is a stress concentration, you can put extra piles, or I mean that depends on 3D analysis of the raft actually in that case. And it's not such a question that can be probably answered in 2-3 minutes time, but then it has to be done. The study actually has to be done independently, and that has to be resolved. The pile draft will require that the raft actually doesn't have sufficient capacity, and it will tend to settle. And that settlement is very important, because when the settlement happens, pile capacity gets activated. Without the settlement of raft, the pile will not, the load carrying by the pile will not get activated. What tends to happen in normal cases is you either provide, or you tend to provide full piles carrying the full capacity. So it is basically a raft supported by piles of full capacity piles, and rarely you will find that a raft is designed as compensatory, that is with the strain compatibility, where the pile settles by pile and raft settle together by amount delta, or that is say 5 mm, 10 mm, 12 mm, whatever the chosen value is, and that is how it would be.
Yeah, so it will not be possible to have this kind of a system where we are using end bearing piles. Right?
Yes, true.
Yeah. So I think we have done with most of the questions. There are still few questions which are not answered, and they are been posted just now. So I think we will we'll answer those questions separately through via mail. And I think now we should close this session. So I would convey the vote of thanks. So we had three interesting sessions today. And if you see, we covered 3 T's in today's webinar: the type, the termination criteria, and the testing of files. So Mr. Jayan Kulkarni covered the various types of file, the methodology of construction, and the criteria for selection. Mr. Vaishnapan covered the file termination criteria and the formulae this is to be used. And Mr. Pandeyji covered the type of tests that are required to carry out. So I take this opportunity to thank all these 3 eminent speakers, and Also to all participants who attended this webinar, and also the support staff who made this webinar possible, especially Reshma, Viha, and Anand Kute. With this, I conclude today's session, and there will be a feedback form available in the QA box, and all of you are supposed to fill up that Google form again. The same Google form will be displayed, and so that will give us some idea about the effectiveness of this training, and it would be a sort of assessment for all of us. So I think with this, I would like to conclude today's session, and we can go ahead with the Google form. So thank you again. So there is a Google form available in the chat box again. This is a post-assessment form. So we are giving 10 minutes time. This session will continue for another 10 minutes, and then we will close this session. So till that time, we can fill up this form. Thank you. Thank you again. Reshma, there is a request to share the Google form again. So it's shared.
Yes, sir, it's shared. It's in chat box.
I think still few participants are facing some problem with the Google form. So is there any way that we can upload this on our website?
Yeah, we'll upload it. If few of them are not able to download it right now, please don't worry. We'll upload on website or we'll mail you. That is for self-assessment and also helping us. But whosoever has downloaded, please continue and complete.
Yeah, it will be the same form. So there are some questions that this is the same form. Yes, it's the same form. So as we mentioned at the beginning of this session, that there'll be pre-assessment and post-assessment. So you can judge the knowledge gain, and we can also judge ourselves that how effective we were in presenting the imparting the knowledge. So if you score more, we'll be happy, and you should be also happy. So Reshma, you can close this session at 7 p.m. We have still 5 minutes to go.
Yeah. Okay, sir.
Reshma, we have
Yes, sir.
we have finished with the time that we allotted.
Okay.
So I hope everybody has who were trying to complete the Google form, they must have completed by this time now because all the questions were known and you have to just answer it with the background of today's webinar. So with this, I think we should conclude today's session. Thank you.